Hello and welcome back to my channel, Chatterjee Tutoring. In this video, we'll be talking about Leetcode's easy problem number 198, house robber. First of all, let's see what the problem actually is. It's actually very simple. You're given a list of houses, let's say this one right here, and your task is to rob the most amount of houses and get the most amount of money. Any house that you pick, you can rob that house. But there's only one catch. If you rob two adjacent houses, which are two houses next to each other, then the police will come and catch you. So you have to find out the most amount of money that you can rob without robbing two houses that are next to each other. Let's take a look at an example. If you're given this list of numbers, 1, 2, 3, 1, which is the example over here, you can rob houses 1 and 3. And since you robbed house 1, you cannot rob house 2 anymore. Since you robbed house 3, you cannot rob house 4 anymore, because both of these are adjacent to houses that you already robbed. So in this case, the amount of money that you robbed is 1 plus 3, which is equal to 4. This number 4 is actually the most amount of money you could have earned in this situation. Because, for example, if you first robbed the house number 2, then houses number 1 and number 3 would not be available anymore because they are adjacent to the house you just robbed, which is number 2. Therefore, the only house left is house number 4, which has 1 money in it. And then the total amount of money you earned this time is 1 plus 2, which is 3. This is definitely less than 4. So the maximum amount of money that we can earn from these collection of houses is equal to 4. Let's take another more complicated example this time. Here we have 5 houses with the money in each house being 2, 7, 9, 3, and 1. In this case, the most amount of money you can earn is first taking the first house, which has amount of 2 money. Then since you took this house, you cannot take the second house. Then you take the third house. Then the fourth house is also gone, so you have to take the fifth house. Now the amount of money you earned is equal to 2 plus 9 plus 1, which is equal to 12. This is the answer for this example. So how do we solve this problem? First of all, you might think to just take the maximum and then see which houses are left, which houses are available to rob, and then take the maximum of those. For example, here you can see the maximum is 9. So you take those, you cross out the adjacent ones, and then you see the maximum is 2. And then there's also 1. This works in this situation. But for example, if we had a collection of houses that is 10, 15, 10. Then if you just took the maximum, then you would only take 15 and leave out these 2. But in this case, that is actually not what we want, because what we want is to take the outside 2, each of which is less than the maximum, 15, but combined, they become more than 15, because 20 is greater than 15. So this approach will not work. Another approach we can try is to step through the houses linearly and at each position see what our best option is. For example, if we start at position number 0, let's say these are 0 indexed. So we start at position 0, and at each position, the maximum amount of money that we can get is equal to the maximum or the greater value of either robbing that house, which is houses at I, plus if we start robbing from I plus 2, since we cannot rob I plus 1. And that is one option. The other option is that we do not rob the current house and only rob the next house, which is rob I plus 1. Now let's see this approach in action. First, we start at the first house, position 0. Now we have 2 options, either rob this house, 2 plus whatever we get from the next two houses, or we can not rob this house and go directly to the next one. So looking at the first option, we start from house number 2. Now if we rob this house, then we have to rob the next to next house, and this approach eventually gets us to 2 plus 9 plus 1, which is 12. Now if we did not rob the first house, then we would get 7. We could not rob house number 2, so we go to house number 3, and we get 7 plus 3 is equal to 10. So the amount of money that we rob starting from position 0 will be the maximum of these two, which is obviously 12. If you are interested, here's the code for the solution that I just described. First, we just want to rob from starting from the position 0, and at each position we have two options: either rob the current house and move down 2 houses to the right, or do not rob the current house and just move 1 house to the right, and return the maximum of these two options. Now this will work, but this is actually very slow solution. If I go to my submission, you can see that I got time limit exceeded on a relatively large input. So why is this solution so slow? This solution is so slow because we are actually repeating a lot of our calculations. If we start from position number 0, we either jump to position number 1 or jump to position number 2. Now let's see this robber that's at position number 1. He can either go to position number 2 or to position number 3. Now if he goes to position number 2, then we already calculated this value in our first run through, but here we are actually calculating it again. Because we do not check if we have already calculated it, we just calculate it again. Because we do not check if this position has already been calculated, we just calculate it again. So there becomes a lot of repetition in what we are calculating. We can actually prevent this repetition of calculation if we use something that's called memoization. Memoization is a tactic that allows us to store what we have previously calculated so that we can check if we have already calculated it, then there's no reason to calculate it again. In this case, for example, when we first go to this position, we can store that, the maximum value that I can rob if I'm at this position number 2 is actually 10, because we just robbed the house number 2 and house number 4, we get 9 plus 1 is 10. So we store 10 into this position. Now, once we jump to this position and then jump here again, we can see that 10 is already stored here. Since nothing has changed between the first time we got here and the second time, we can take the exact same value and pass it back instead of jumping to the next one again. And as you can see, there's a lot of repetition in where we jump to. So this actually helps a lot with our runtime. And this is how we implement this memoization technique. First, we have to store a global integer array called memo, and then we fill it with -1 initially so that we can know if we have already calculated the given position or not. Now, each time we go to rob a house, we check if we have already calculated the current position. If it's greater than equal to 0, which can only happen if we set this memo at I to somewhere else, then we just have to return this memo at I without having to calculate anything else. If we have not though, then we actually have to still calculate it and calculate the maximum, and then we can just return this value. Now for my submission, as you can see, this passed with very fast runtime, but the space stored was pretty large. This is because we are creating a whole nother array with the same size as the input, so the space complexity for the solution is O of n. This approach that I just showed you is called a top-down recursive approach with memoization, Because we start from the beginning, we go all the way back, and then we come all the way back again. But what happens if we, instead of starting from the beginning, going all the way down and coming back again, we actually start from the beginning and work our way backwards? What I mean is this. If we start with an empty array as an input, then obviously the result is 0, because we cannot rob anything, so the total amount of money we can rob is 0. Now let's say we are only given one house. Let's say 2. Then we have two choices. Either rob it or do not rob it. If we do not rob it, then we get 0 money, but if we rob it, then we get a positive amount of money. So we obviously want to rob it. Now, if we are given 2 houses, then we just take the maximum of the 2 houses that we are given. Because if we rob one house, then the other house is out of the question, because we cannot rob 2 adjacent houses. Now let's say we have 2 other friends, the green robber and the red robber. The green robber only knows that there's one house, and he can only see that house and all of the houses before it. In this case, he can only see the first house. The red robber can see one house after the green robber. So all the green robber can see is 2. All the red robber can see is 2 and 7. So the red robber's maximum value that he can rob is 7, while the green robber's maximum value is 2. Now, once we get to the house after the red robber, we can make our decision based on what the previous 2 robbers have. Our decision is either we rob the current house and take whatever the green robber has, or we do not rob the current house and take whatever the red robber has. In this case, the question is either rob the current house and take what the green robber has, which is 9 plus 2, which is 11, or the second option is just take what the red robber has and we are left with 7. So in this case, the answer, if we were robbing up till this house number 3, which has a value of 9, the answer would be 11. Now we can step one more house to the right and we come to the value of 3. And the green and red robbers have each moved up one step also. So now the red robber sees a value of 11, the green robber sees a value of 7, because each of them just moved up one house. So we can repeat the same process again. Either take the current house and whatever the green robber has, which is 3 plus this 7, which is 10. Or we can not rob the current house and just take what the red robber has, which is actually this value of 11 right here. So the choice is between 10 and 11, and definitely we'll pick the 11. Now we come to our final house, which has a value of 1. Now we can again repeat the same process. We can either take 1 plus 11, which is 12, or we can take just the previous one, which is 11, and we get our answer, which is 12. If you remember, this is actually the correct answer, but we got it without having to store any extra arrays. We only have to store our 2 friends, the green and the red robbers. And this is how this last solution was implemented. In this case, prev 1 was our green robber and prev 2 was our red robber. And at each position, I, prev 1 is 2 steps behind I and prev 2 is 1 step behind I. And each of them hold the maximum amount of money that we can earn if we stopped at that position. Therefore, for each position, we can just use the formula maximum of robbing the current house plus prev 1, which is 2 houses behind us, or just prev 2, which is only 1 house behind us. This type of solution for this problem is called a bottom-up solution, because we start from the base case where we only look at either the first or second houses, and we work our way up to looking at all of the houses. The previous solution that I showed was called top-down dynamic programming with memoization, because we started at the beginning and worked our way down to the last one, which is the bottom. And that is it for this video. If you like this video, please leave a like and subscribe to the channel. And if you had any questions on how this code works, then you can leave a comment in the comment section.